And are there any questions before we get started? Great. No questions. Can everyone say hi to me so that I know that you can hear me? Let's get started. Hi. Yay. Thank you. Okay. So welcome to week 11. There's an echo somewhere. I don't know why there's an echo. Are you guys hearing an echo? Okay. Okay. Okay, good. Then it's just me. Maybe it's my ears. Okay. We are going to talk about absolute value. We're going to graph them later, but we're also going to solve them. Square root functions and quadratics. Okay. So let's talk about the parent functions. Okay, so the parent function is the most basic function. We will see parent functions when we graph, but also when we solve. So the parent function, absolute value of x, is equal to, let's say, the number 5. Okay, so solving with absolute value, we are expecting 2 answers. Good morning, welcome. Okay, so x could be 5 or -5. Okay, because if I put 5 in, the absolute value of 5 is 5. The absolute value of -5 is also 5. So the parent graph for absolute value, we are expecting 2 answers. Now, square root. The square root of some number equals 5. Okay, with the square root, we are expecting 1 answer. So the square root of what number equals 5? We need to think backwards. Let's do this one first. The square root of what number equals 4? Does x equal 2 or 16? 16. The square root of 16 gives us an answer of 4. Does that make sense? Okay, so now let's do this one. The square root of what number equals 5? And it is not a decimal. So Zoomers, can you type in? The square root of what number equals 5? Let's see, chart of factors, table of powers. The square root of what number equals 5? The square root of 25. Do we see it? The square root of what number equals 5? The square root of 25 equals 5. 5 is going to be the answer. So, okay, so x would be equal to 25, 1 answer. Okay, and then x squared equals 5. No, x squared equals 25. Okay, the answer is 25. Number 1, what number when I square it is going to give me 25? And number 2, how many answers am I going to get? So what number squared gives me 20? Still there, right?
Wait, to find the square, is it 2 numbers and 160?
The same number that multiplies by itself. So can we see, we could solve this by taking the square root of both sides. Now, this is really key. Square root and squared are inverses. They cancel each other out. So the square root cancels with the squared and I get x. And with your calculator, the square root of 25 equals 5. Yeah, because 5 squared equals 25. Does that make sense? Okay. But with squared, there's 2 answers. Excuse me. So 5 squared equals 25. There's something else. When you multiply it by itself, don't do that. Contagious. Equals 25. What times itself? What is another number? Oh my gosh. -5. Yeah, because a -5 times a -5, when you multiply 2 negatives, you get positive 25. So absolute value, 2 answers. Square root, 1 answer. And I'm going to clean this up. This is a quadratic, 2 answers. Okay. So first of all, this is absolute value. So the parent graph, I am expecting how many answers? Yeah, Zoomers? How many answers? Awesome. So I'm expecting 2 answers. So this is what we're going to do. And I would like you to do them in this order. Isolate the absolute value. Split and solve. Now, some of you are going to split it at the beginning, and that will work some of the time. But if you want it to work all the time, we're going to isolate the absolute value, then we're going to split, and then we're going to solve. So this is hooked in together. We're going to split it later. What can I do to isolate my absolute value? What number has got to go? The 7. So I'm going to multiply not 7 over 7, 7 over 1. Right? Not a 7 to the top and the bottom. We're going to do the same thing to the left as we do to the right, and it's going to stay balanced. 7 on top cancels with 7 on the bottom. So I have absolute value of 6a plus 3 is equal to how much? Correct. How much, Zoomers? Oh, careful. What's on the right-hand side? All right. 28. Now, I've isolated my absolute value. These are not ones. These are absolute values. Yeah. Next, we're going to split. Okay, there's 2 ways to do this. So we're going to do it. Okay, we're going to do it the long way. So we have 6a plus 3 is equal to 28. And the opposite. Does that make sense? Before we had the 5 and we had the -5. Now we're going to have 6a plus 3 and -6a plus 3. You with me? Okay, let's solve this one. -3 6a is equal to 25. Divide by 6. A is equal to, leave it as a fraction, please. 25 over 6. Now, can that be reduced? No, because there's no common factors. Okay, now we have to solve the other one. Now, we can either distribute the negative or divide it and make it go away. So we're going to divide by -1 before it gets distributed. It's going to save us a step. So before distributing, we're going to cancel. So we're going to have 6a plus 3 is equal to -28. Subtract 3. 6a is equal to -31. Divide by 6. A is equal to -31 over 6. 2 answers. Absolute value, we're expecting 2 answers. Okay, 2 and 3 are on your own. Or you can request them at the end. Let's go on to number 4. So number 1, parent graph. The square root function is going to give us 1 answer or 2 answers. All right, ding, 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 1 answer. So we're going to isolate. We're going to square both sides and we're going to solve. Okay, we're going to isolate the variable. We're going to isolate the square root. Those guys are locked in that house. So what number can I get rid of to isolate the square root? Correct. Yeah, Zoomers, what number am I getting rid of first? Now, not the 15, because the 15 is on the correct side. Try another one. Yeah. I'm isolating the square root. The 15 is already on the left-hand side. I need to get rid of what number? Five. All right. Ding, ding, ding. Now I cannot get rid of the 25 because it's locked in that square root. Okay. That's why, oh, wow. That's weird. So that's why it took so long and I wanted you guys to process this. Can you see that I'm getting rid of the 5? I am isolating the square root. So now I have 3 is equal to square root of 2k plus 25. The 2k and the 25 are locked in that house. So now I need the inverse of square root. So the inverse, the thing that gets rid of square root, is squaring. So let's try. Let's over here, scratch paper. 7 squared is what? 49. I think I'm going to need a new battery soon. Okay, square root of 49 equals 7. Yeah, do we see how they're inverse operations? Now, what would be the square root of 7 squared? Final answer. What is the square root of 7 squared? And then take the square root and you get. Yeah, Zoomers. Can you see that the final answer is 7? Because 7 squared is 49. The square root of 49 gets back down to 7. So the square root and the squared cancel each other. Super important. Oh, it looks like a smiley face. Super important right there. Okay. So now I'm going to square both sides to get rid of the square root. So 3 squared is 9. So what happens right here with the square root and the squared? They are going to cancel each other. Yeah, the square root and the squared cancel each other. And the 2k plus 25. Okay, 2k plus 25 are now set free. In order to set them free, you have to square both sides. Okay, next, what are we going to do next? Awesome. Subtract 25. So we have 2k is equal to, thank you. I didn't know. Negative 16. Divide by 2. K is equal to negative 8. Yeah? Bye-bye. One answer. Okay. Let's do another one. You know what? Let's do a simple one. Not quite so complicated. Wait, is this one simple? Okay, we're going to do number 6 and then we'll go back to number 5.
Wait, how come the questions here have one answer and it's
Okay, so absolute value will always have 2 answers. Square root will always have 1 answer. The ones below, x squared, will most of the time have 2 answers, and we'll talk about that later. Okay, we're going to do a simple one, and then we'll go back to 5. So, parent graph. Square root function, I am expecting how many answers? Yeah, Zoomers, square root function, I'm expecting 1 answer. Okay, we're going to isolate the square root. Is there anything outside the square root that can break away? Anything outside the square root that I can get rid of? Yeah, do you see that that's a no? I cannot add 1 because it's locked in that house. Okay, there is no isolating to do. What's the next step? Square both sides. Yeah, so I'm going to square both sides. I'm going to do the inverse operation. So squared cancels with square root, and I get 5n minus 1 is equal to 49. Next step. The 5n and the 1. Okay, now we're going to solve. Okay, who moves next? Okay, we're going to add 1. 5n is equal to 50. And the last step is divide. N is equal to 10. 1 answer. Okay, but do you see how important it is to write down that I'm expecting 1 answer? Otherwise, I'm going to get to the end and maybe there was supposed to be 2 and I forgot. Okay, let's do this one. Parent graph, square root, 1 answer or 2 answers? 1 answer. Isolate. Okay, this is tricky. Now, Taylor Swift song. What is it in between the 7 and the square root? I've got a blank space, baby. Yeah, do we see we have a blank space in between the -7 and the square root? This is multiply. So to isolate the square root, I need to get rid of the -7 that is being multiplied by the square root. So how do I get rid of a -7 being multiplied? I'm going to divide by -7. Can you see how it'd be so easy to think, oh, add? No, 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 no. She look in between the 7 and the square root is a blank space. Taylor Swift would say multiply. So cancel the -7s. And I have square root n over 5 is equal to +10, which is good because I need the other side to be positive. Otherwise, I get an imaginary number. Talk about that later. Okay, what's the third step? In order to get rid of the square root, what do I have to do to both sides? What did you say? Oh, careful. Opposite of square root is? Opposite of square root is, what am I doing to both sides? Ding, 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 squaring both sides. Yeah, square root. Awesome. Okay, so the squared cancels the square root. Most important thing you're learning today, squared cancels the square root. So what comes down? N over 5 is equal to 10 squared is 100. Okay, now I need to get rid of the 5. I need to isolate the n. So what do I do to both sides to get rid of that 5? Multiply by 5. 5 over 1, right? So we have n is equal to 500, and I was expecting 1 answer. Okay, so we have absolute value, we have square root, and now we have a quadratic. If it's an x squared, it is a quadratic. Notice there is no x term. Don't write this right here because we need to solve. Notice there is no x term. You know how when we usually factor, okay, no b term. I didn't mean x, no b term. Yeah, I would have b squareds, I would have b's, I have constant terms. There is no b term. It is called the linear term. It has a variable, but no exponent. Okay, so we are going to solve. So the parent I'm expecting how many answers? 2. Okay, exponent of 2, 2 answers. So next step, I'm going to isolate. I'm going to isolate my variable. I'm going to get rid of anything attached to the variable. So it is alone. Next step. Not yet.
Oh,
So think of, please excuse my dear Aunt Sally. We're doing the least powerful first. If you're in a war and you're going to attack, you're attacking the least powerful players to get rid of them first. Yeah, Zoomers, what do I do first? I want to attack the least powerful player. I'm going to add 6. See how that's the one that's loosely attached? The least powerful player. Okay, minus 6 plus 6 cancels. So I have 25b squared is equal to 25. Okay, I'm isolating my squared term. Okay, so next I'm going to divide okay, so b squared is equal to 1. So expecting 2 answers, isolate your squared term, and then once your squared term is isolated, we take the square root of both sides. So square root of both sides, the square root cancels the squared. And I get b is equal to square root of 1, and the square root of 1 is 1. Any comments? Are we good? Are we done? Uh-oh, we have a problem. What is the problem? Okay, let's go back up to here. I was expecting 2 answers. Okay, the 2 answers come from this step. Okay, so we have 1 or -1. Yeah, because -1 squared, negative times negative is positive, is also equal to 1. Yeah, so we're expecting 2 answers. Okay, number 8 is on your own. It's going to come out a fraction, but you're going to be okay. Let's move on. Now I'll do these at the end if you want to request them. Okay, odd, even, or neither. Now, in geometry, last year, if I was your geometry teacher, I don't have as many. You weren't in my class, were you?
that was interesting.
Yeah, okay. Anyway, you talked about, whoever your geometry teacher was, you talked about reflection across the y-axis. Okay, in geometry, you talked about reflecting things across the y-axis. So for example, if that wasn't here, I wanted to take the left, I wanted to reflect it across the y-axis, and I would get the right. Okay, and the y-axis is also the axis of symmetry. Okay, the left side is the same as the right. Now, if you were all in person, we would fold a piece of paper right here. Can you see that if I folded it, it would match up? Yeah. Okay, so if something has reflectional symmetry across the y-axis, the function, if this was a function, this would be an even function. Now, we're going to identify them visually. There's also an algebraic way to do it. If you want to photomath it, it'll give you the algebraic, but we haven't covered that yet. So if you prove to me this like fancy dancy algebraic way, I'm going to be like, wow, that's very nice, but we haven't covered that. Okay, so little pet peeve there. On the online exam, I'm like, forbidden to use calculus on this exam, because sometimes I see these methods and I'm like, whoa, that's calculus. Nice job. Okay, sorry, venting. Okay, so this butterfly would be an even function. We are looking at them visually. We are not solving them, proving it algebraically.
So basically they match.
Yeah, can you see that this is absolute value? Can you see that this is an even function? Yeah, you can fold it and they match. This is an even function. Yeah. Now, it's not just folded anywhere. The fold has to be the y-axis. Okay. Even function. Yeah. Can you see that we could fold it right there? So this is even. These are all examples of even. Okay, and there are the graphs. The simplest even function is y equals x squared. What a coincidence. The exponent is even, and it is an even function. Now, not all parabolas are even, because what if I move it over here? Is this one even? No, it's not. I can't fold it anywhere I want. The fold has to be the y-axis. So this would be no, it's actually neither. Okay. So, okay. So number 9, even. Yeah. Now let's look at number 10. Okay, I'm going to try to be super tricky. Let's see if I can be super tricky. This is so much easier in person. It's odd. I can't reach it. I can't open this up. Oh my gosh. Wait, maybe I could do this. What happened? Oh, I was going to be tricky. Right there, grab it. Okay. Ding, ding, ding. I'm so tricky. I am so high tech. Are you guys so impressed with my technological ability? Okay, you're like, I don't see what you're doing. Here it is. Okay, is everyone looking at number 10? Now, yeah, you're all looking at number 10? Rotational symmetry. If it's odd, I didn't mean to do that. If it's odd, that means, and I can't write on this. Yes, I can. Because I am so high tech. Yeah, please, please. Okay. If I can rotate it 180 degrees, then it is odd. Okay, so let's see if this is odd. Now, if you Google even and odd functions, there are algebraic ways to prove it. You're going to do that next year in math analysis. We are doing it visually. So here I go. Everyone watching my technology, rotating it 180 degrees. Can you see that after rotating it, the words are upside down? The function looks the same. Okay, so if you take your paper and rotate it upside down, can you see that the new one looks like the old one? Yeah, do you see it?
So if it does that, it means it's off.
If it has 180 degrees rotational symmetry, then yes, it's odd. So going back to so this is odd. Okay, if you can fold it, it's even. Fold it on the y-axis. If you can rotate it 180 degrees, it's odd. This one, is this even? Can I just fold it anywhere I want? No, it has to be on the y-axis. If I folded it on the y-axis, would it match up? No, this is neither. So, little confusing. It could be an x squared and not be even. Okay, you have to fold it on the y-axis. Okay, graph. We did these last week. Let's see what you remember. The parent graph of the absolute value. Absolute value makes a V. Yeah, not an upside down V because that's positive. Absolute value makes a V. Now, this is also plus 0. The next thing I want is the what? Vertex. Another V. So we have opposite, same. Does anyone want to guess what the X and Y coordinates of the vertex are?
0 to 8.
Okay, the X coordinate is -1. The Y coordinate is 0. Yeah, opposite of what's inside the absolute value, same, and there wasn't anything out there, so it was just a 0. Okay, let's make a table. So -1, 0 is the vertex. It goes at the middle of my table. So -1, 0. Okay, you with me? Does it look familiar? Does it look like something we talked about last week? Okay. 1 to the left is -2. 1 to the right is 0. So I'm going to plug in -2. Y equals 3 times absolute value -2 plus 1. So that's 3. Do the absolute value first. Okay, what do I do next? This is where everyone makes the mistakes. The absolute value, what's the absolute value of -1? Yeah, do we see that that's 3 times 1 equals 3? So this one's 3. Okay, now let's plug in 0. Y equals 3 times 0 plus 1. So what is that going to give us? Three times 1 equals 3. And with absolute value, those two, if you really did grab the vertex, those two should match. So I just checked it and it looks like I'm good. So -2, 3 and 0, 3. And this one reminds me of Rudolph, the red-nosed reindeer with the little eyes and little nose, little antlers. Yeah, so this one's Rudolph and it matches the parent graph. Number 13. Okay. Number 13. Parent. We learned last week that square root is a sleeping parabola, right? X squared hugs the y-axis, square root of x hugs the x-axis, but it only has one arm. And this is plus 0 again, because there's nothing over there. The vertex. Okay, anyone ready to guess the vertex of this function? Opposite. Same. Okay, so what is the x coordinate of the vertex? Yeah, it's the one with the x. So opposite sign. The x coordinate is +2. Thank you. The y coordinate is 0. So let's make a table. And 2, 0 goes in there. Notice the vertex. Are there any points to the left of the vertex of the square root? I wonder. Okay, let's plug it in. So 2, 0 is the vertex. 1 to the left would be 1, 1 to the right would be 3. So let's plug it in. Y is equal to 3 times the square root of 1 minus 2, which is 3 times the square root of -1. And what's the square root of -1? Error. It is an imaginary number. So there is no point to the left of the vertex. Yeah. Okay, let's plug in 3. Y equals 3 times 3 minus 2 plus 0, which is 3 times absolute value. Oh my gosh. I'm so sorry. I switched to absolute value. 3 times 3 minus 2. Which is 3 times square root of 1. Square root of 1 is 1, which is 3 times 1 is 3. So 3 is 1, 2, 3. This is a very tall square root function. Okay. Let's do another one. Parent. Vertex. And table. Okay, parent. Square root function is a sleeping U. Vertex. Hey, you guys should be able to give me the vertex. Now, see, isn't this great? Because you learn it for one and the same rules apply for all of them, which is nice. It's very, your brain is like, okay, I'm good. I'm good with this. -6, +2. Awesome. Yeah, just like the absolute value. Okay, so we're going to put that as in the middle of our table. Now, if you want to make a table with the 10x values and 10y values, that's fine. I am lazy. I only want to make a table with 3 values. So I want to make sure I grab the vertex and put that in the middle. Okay, so -6, 2 is the vertex. So what other points should go into my table? X equals -5. I'm going to put that there. And -7. Yeah, one to the left, one to the right. Okay, make that one go away. Okay. So let's plug in y equals square root -7 plus 6 with an outside +2. -7 plus 6, square root of -1 plus 2. The square root of -1 is imaginary. It's an imaginary number. It's like a Halloween point. It's a ghost, right? There is no real number. It's imaginary. Now let's do -5. Y equals square root of -5 plus 6 plus 2. Which is square root of 1 plus 2. Square root of 1 is 1, which is 3. And we know we could do more points. We know that it is a sleeping parabola. And then this part's under the covers. You can't see. So there's only 1/2 of the sleeping parabola. Okay, 15. Parent. Exponent of 2 makes exponent of 2 makes a U. Isn't that handy? Exponent of 2 makes a U. But we have a little problem right here. We have a negative in front of the function. So this is not your normal U. This is a sad U. Yeah, that is the parent. That's what I'm expecting. Okay, sad U. A negative in front makes it a sad U. Okay, everyone should feel comfortable giving me the vertex because it doesn't matter which function, we grab the same vertex. So very carefully grab the vertex, please. Okay, Zoomers, what's the vertex? Yay, +1, 4. This is the opposite, and this is the same. Okay, make a table of 3 values. And what absolutely needs to go into your table? The vertex. Got it. Awesome. Okay, 1, 4. Huh. It doesn't look like this graph left me much room up here. Let's see how this works out. Okay, 1. 1 to the left is 0. 1 to the right is 2. Y equals negative 0 minus 1 squared plus 4. Okay, let's talk about simplifying expressions. Parentheses, exponents, multiply, divide, add, subtract. So first I'm going to do the parentheses. And next I'm going to do the exponent. So that guy right there, weights, -1 times -1 is 1. So that's -1 plus 4 equals +3. Now, I am not totally sure that my arithmetic is correct, but I know it's going to be an upside down U. So if that number is like here, you're like, maybe I should look at that again because I know what the shape is going to be. Let's plug in 2. Y equals -2 minus 1 squared plus 4. We're going to do parentheses first. I'm going to do exponents second. Okay, now this should make an upside down U. 0 is 3. 2 is 3. Nice. There we go. Yeah. So those negatives are a little bit tricky. This one on your own, shouldn't write all over the graph. Okay, parent. What is this going to look like? Absolute value makes a V, but this one is going to be an upside down V. Vertex. The vertex is 0, comma, +3. Yeah? Can you see that the number in there with the X is 0? So let's make a table. Zero, 3. Put the vertex at the center. 0, 3. Okay, 1 to the left is -1. 1 to the right is 1. So negative, absolute value -1 plus 3. Yeah? Now, this negative does not cancel the 1 inside the absolute value. Okay, it can't break through the wall. So the absolute value, what is the absolute value of -1? Yeah, it's 1, right? The negative weights, and this comes down as a +1. See how tricky that is? And guess what? You can't use your calculator. The calculator does not have an absolute value button. So this is -1 plus 3 is 2. Okay, let's do this one. Y is equal to the negative absolute value of 1 plus 3. Negative 1 plus 3 equals 2. Negative 1 is 2. 1 is 2. Upside down V. So predicting the shape is more accurate than actually plugging in numbers because you have so many opportunities to make an arithmetic error. Okay. This is different. Cubic. Okay. This one is, Zoomers, you're missing out. King Tut. Yeah. You guys don't know that because there's a great song in the 80s where they go, born in Arizona, moved to Babylonia, King Tut. Okay, so Steve Martin, King Tut song. This is your assignment. Google it. Born in Arizona, moved to Babylonia, King Tut. Okay, so the cubic looks like King Tut. It looks like your arms are doing that. So basically, I took a parabola, except now the positives go up, the negatives go down. So it's like a parabola where the negatives are now going down. So that's the parent. Now we have never done a cubic before. Anyone have a guess what the vertex is? Ding, ding, ding. +2, +1. Okay, let's make a table. And let's put the vertex in the middle of the table because we want to catch a snapshot. This is just a sketch, but we want it to be accurate. 2, 1. Okay. 2, 1. 1 to the left is 1. 1 to the right is 3. Y equals 2. 1 minus 2 cubed plus 1. We can just plug that right into the calculator. It's going to go 2 times -1 cubed. Now, what is -1 cubed? Careful, there's 3 of them. It's negative, right? Because those are going to cancel. So this is 2 times -1 plus 1, which is -2 plus 1 is -1. Okay, with a cubic, the right side, they're going to go up. The left side, they're going to go down. Okay, let's plug in 3. 2 times 3 minus 2 cubed plus 1. 2 times 1 cubed plus 1. 2 times 1 plus 1 equals 3. Okay, so 1 is -1 and 3 is 3. So it looks like a parabola that the left-hand side has been twisted to go down. It's a cubic. Now, let's talk about the value A. A is the coefficient right there. You could also see it here. Can you see that I go 1 to the right, up 2? I think you might have a homework problem that says, look at the graph and tell me what A is. 1 to the left, down to. We're going to talk about A later. Okay, I realize you guys are exhausted. Let's move on to 19. Woo, crazy. Okay, we're going to talk about later how to find the y-intercept. Right now, we're going to use the chart. Okay, y equals x would look like that. Y equals negative x would look like that. Y equals x squared would point up. Y equals negative x squared. My pen is dying. I think I need a new battery. Y equals negative x squared. Okay, this is y. A degree 3 means y equals x cubed. Now, this one obviously has more terms, so it probably looks more like this. Y equals x cubed plus 7x squared plus 4, blah, blah, blah. It has more terms. Yeah, but the parent graph is x cubed. Y equals negative x cubed would flip. Yeah, this is y equals x to the fourth plus other terms, y equals negative x to the fourth would look like that. Y equals x to the fifth, y equals negative x to the fifth. 1, 2, 3, 4, 5. Okay, these are going to be the easiest problems. Okay, now later we'll talk about finding the y-intercept. We're just going to talk about end behavior. So we're going to sketch based on the end behavior. If you give me a perfect graph, I'm going to know you plugged it into Desmos. That's not what we're doing. Sketch. So x to the fourth looks like this. But this is negative x to the fourth. So it's going to look like this. That is a sketch based on end behavior. That is not a graph. I did not plug it into Desmos. I am using the graphing calculator in my mind and the table. And when you come to take the test, I give you, here's the table. Okay, negative x cubed. Y equals x cubed looks like this. So negative x cubed, flip it. Okay, I want you to see a polynomial and visualize it in the graphing calculator of your mind. You have a graphing calculator in your mind. So this is not Desmos. Okay, notice the lead term is positive. So looks like that. Lead term is positive. Doesn't matter the other terms. Lead term, most powerful term. X to the fourth. Look below at the table. And this is degree 4. Sketch, not an accurate graph, because I want you to use the graphing calculator of your mind, not Desmos. Okay, I promise when you come in to take the test, these will be the easiest ones. So you just got to understand how to use the chart. Okay, domain and range. The domain are the possible x values. So I'm going to draw a box around this function. Are there any x values outside the box? So x is in between. Okay, so only look at the x-axis. The x is in between, starting with the negative, right? We're going small to big, left to right. X is in between -5 and +1. Now, notice my circles are different. So on the one end, it's equal to. So this is in between. -5 and +1, it is also equal to -5, to 1. It is not equal to -5. Or we're going to use, okay, I forget what it's called. Interval notation. So we go from -5 to 1. Now notice loose grip on the -5 does not touch. Firm grip on the 1 does touch. So you should know both notations. The range is the y's. Okay, I'm just going to do interval notation. The y's go from -3. Do you see where I got the -3? Yeah, because right now I'm doing the y's. And it's actually touching the -3 to +1. Firm grip. Okay, so math. When you learn a new concept, the first time you see it, you're like, what? I will never, ever understand this. And then with practice, you do. Let's look at this one. The domain. Now look at this. Can you see that it's getting wider and wider? The domain goes from -infinity to +infinity. There is no boundary on the x's. It goes forever to the left and forever to the right. The range. Now, it goes up to infinity, but the y-axis, the y values actually have a bottom. And what is that bottom number for the y values? Time for you. Oh, did someone just guess that? Awesome. Yeah. Can we see that 1 is the bottom number for the y values? So it starts, and it actually firm grip on the 1. It actually hits the 1. But you can never hit infinity. Now, this is rushed. It's at the end. I realize your brain feels kind of full. We're going to talk about this more later. 25. That didn't help. Okay, the domain. I'm just going to tell you. Look at the X values. It goes from a certain X value to infinity, and we can never have a firm grip on infinity. Can anyone tell me what the lowest X value is? Oh, nope. X, we're looking at the X axis. The lowest X value, oh, ding, 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 right here. Can you see that -2 is the lowest X value? Yeah, you have to flatten it and look at the X axis. Okay, the range. Now we're looking at the Y, and I'll tell you it goes up to infinity. What is, looking at the Y axis, what is the lowest Y value? And my computer's freaking out. We're going to ignore that. Okay, what is the lowest? Okay, I think that number's for this one. 1. Can you see that 1? The domain is the X's, the range is the Y's. Yeah, 1 is the lowest Y value. That was supposed to be yellow. Okay, last one. I know you guys are dying. You can do this. Your brain feels full. For the cubic, the domain, look at those arrows. Can I put a boundary on the X's, or does it keep going wider and wider? Okay, negative infinity to positive infinity. And the range, negative infinity to positive infinity. Yeah. Okay, we are done. Now, if I skipped anything and you want to request them, you can request them. Otherwise, thank you for coming. Thank you for hanging in there. You are awesome. So, any requests, you are welcome. Thanks for coming. And if you want to come by on Friday, there's also going to be chips and cookies and water if you want to come over. You're welcome. And get a passport signed with 4 or 5 core teachers and get some extra credit on Friday, and food if you're available.
Is that here?
Yes.
Oh, like, can you-
You're gonna come here, and then if you want to go outside, there's like stuff out there. I don't know what's out there. Fun stuff. So CTech is having their fun Friday, and we are having connection day, where we just want you to come, say hi to all your teachers, get this passport signed, say hi to all your teachers, and we'll give you extra credit and cookies and chips. Yeah. Well, I don't know if all the classes are getting extra credit. My class is giving extra credit. But you can just come say hi to your teachers and get some work done. So this will be a nice quiet room. Okay, Giselle, do you have any questions? Any requests? Okay, we're going to do 16. Take a deep breath, get some oxygen to your brain. Number 16. And this will be on the recording. Oh, thank goodness. For a second, I thought I forgot to start it. Okay, parent graph. Exponent of 2 makes the U, and this one is a happy U. Okay, the vertex. Ding, ding, ding. Opposite, same. Let's make our table. Okay, +1, -1 goes in here. So +1, -1 is the vertex. 1 to the left would be 0, 1 to the right would be 2. Plug in 0 would be -1 squared -1, which is 1 minus 1, which is 0. Plug in 2. 2 minus 1 squared is 1 minus 1, 0. Notice on these, the U and the V, if you really did grab the vertex, those should be equivalent. So 0, 0, 2, 0, happy U. Okay, I'm going to keep going because anyway, anyone want to see 2 and 3? Yeah? Okay. So how many answers? 2 answers. Isolate. This one's a little tricky, actually. Okay. What am I getting rid of? Not yet. Okay, so careful. Watch this. -5. Yeah. Because the sign in front of the 5 is positive. Oh my goodness. Isn't that weird? Oh my goodness. There's still a negative there. That is an invisible 1. Okay, we are still isolating. So what's my next step? Not split yet. We can't split yet. There's one more number we need to get rid of. Okay, divide by -1. Some people split and then distribute it. It doesn't always work. Like it works some of the time. So we're not going to do that. Okay, so now we have 6x plus 3 is equal to +57. And now we're going to split. 6x plus 3 is equal to 57. 6x plus 3 is equal to -57. So split and solve. Okay, so subtract 3. 6x is equal to 54. Divide by 6. X is equal to 9. Okay, I did the shortcut. I did it differently than I did the first one. The first time I put the negative and divided it to go to the other side. Can you see that this time I just went straight to that step? The +28 and the -28. But the reason is you're really subtracting it over. So, like, you see what I did? So 6x plus 3 equals 57, or 6x plus 3 equals -57. Yeah? Okay. So now I'm going to subtract 3. 6x is equal to negative 60. Divide by 6. X equals negative 10. Now, it takes some careful work to get an absolute value where they are both integers and there's no fractions. So, okay, we good on that one? One more. How many answers? Okay, isolate. There's nothing. Yeah, everything is locked inside the absolute value. So now we're going to split. So you can either do it like I did for problem 1 or like I did for problem 2. We're going to do problem 2. The reason is because I just feel like the fewer steps, the better on this. So 3 plus 7n equals 24, and 3 plus 7n is equal to what? Negative 24. It's going to matter once we get into less than greater than, but for these, you can just go right to that step. So now I've got to solve 7n equals 21. Divide by 7, n equals 3. Minus 3, 7n is equal to 20. Negative 27. I don't trust myself. Divide by 7. So n is equal to negative 27 over 7. Okay, so predict 2 answers. Isolate the absolute value. Split into a positive and a negative, and solve. And we are done. And you are awesome, hanging in there. Hour and a half of math thrown into your brain. Any other questions?
For 8, I did it, but you know, you have to like cancel the.
Oh, I forgot. Let's do number 8.
Because I almost finished it, but I got lost in the fraction.
Okay, that's awesome that you actually started. Okay, so the parent graph has how many answers? Okay, so most likely 2. Sometimes it reduces down to 1, but we'll talk about that later. Okay, isolate. So we are going to subtract 7. 64x squared is equal to 4. Divide by 64.
Oh my, I'm not going to.
Okay, calculator. I want you to do I want you to do 4 ABC 64, and we're going to have the calculator reduce that fraction for us. Okay. Next step. How can I cancel an x squared?
By do actually.
Square root. Yeah. Okay. So I have x squared. X cancels, right? So I'm going to split it. Square root of 1 over square root of 16. So I'm going to do them separately. Square root of 1 is 1. Square root of 16 is 4. Or no,
Oh.
negative 1/4. Don't take the square root a second time. You've already taken the square root. So now so once you get to this part, 2 answers. Yeah, because 1/4 times 1/4 is 1/16, and negative 1/4 times negative 1/4 is positive 1/16. Done. Woo!
That was a lot.
It is. It's hard to do one lecture for a whole week of advanced algebra. But you girls are awesome. Isn't it better just to get it all done than to meet every day? Nah, you don't want to meet me every day. You're welcome. Bye-bye. Thanks for coming. Okay. So this will be on the recording. If you feel like, wow, I kind of zoned